Okay, let's take a look at this reaction. So that's what we wanted to happen, but it doesn't go that way. Can you explain why? We will have to talk about it. Okay. All right, let's take a look. So what we wanted to happen. So we start with this. We have alkyl halide and alcohol in the starting material. Add magnesium in ether, so make a Grignard right here. So what we want is this carbon here. There's a nucleophilic center. Attack the carbonyl carbon of acetone. This guy here is acetone. All right. So basically, this is a Grignard reaction, and we want to get this compound, so we get dialcohol. But somehow it doesn't go this way. What's going on? Well, go back to the previous video. We talked about that acidic solvent or protic solvent is not compatible with the Grignard reagent because Grignard reagent react with it, right? Well, this is not in the solvent, but this is actually in the compound. We have an OH, which is an alcohol in the compound. So instead of this Grignard reagent will react with acetone, it will react with itself. Ta-da! Right? So Grignard reagent is really sensitive to anything acidic. Can be present with acidic solvent, can be present with acidic functional group in the compound. Right? So any of these, we cannot make this because of the reactivity. So magnesium gonna go attack here, not magnesium. So this carbon here, the Grignard reagent attack here, deprotonate, deprotonate, deprotonate. None of this works. You cannot synthesize this. But well, what are we gonna do then? We want this, right? But we can't use Grignard. Well, actually we can. This is what we're gonna do. We're gonna put a protection. So we're gonna protect the OH group, adding protecting group on it, so we block it from reacting with anything else, right? So it's stable, stay right there, doesn't do anything. And then you're gonna do whatever you want to do. You do Grignard reagent, you do oxidation reaction, you do whatever you want to do. And then at the end, you deprotect this protecting group. Okay, so these are three core steps. We have protecting step, functional group transformation, and then deprotecting step. Let me show you how it works, all right, with the protecting group. So the popular protecting group for an alcohol is trimethylsilyl chloride or TMSCl. Okay, so we're going to add TMSCl in the presence of triethylamine. Also, triethylamine. So put a trimethylsilyl group on the oxygen right there. Look something like that. All right, and then so the mechanism is really simple. Nucleophilic attack on that silicon. Some of you may ask, hold on, how does the SN2 happening right here? This is tertiary silicon, not like carbon, but this is tertiary silicon, right? Well, if it were to be carbon, of course, this SN2 not going to happen. But silicon is much bigger than the carbon. If you look at the periodic table, silicon is right below carbon. Remember that? So there's a much more space that the nucleophile can approach. Right? So this SN2 is allowed. Right? And then we're adding triethylamine to deprotonate that proton there. And ta-da, you get the OTMS, which is the protected alcohol. All right? After you have gotten the protected alcohol, you're going to do whatever you want to do, functional group transformation. Once you're done, you don't want this protecting group anymore, deprotect it. There are two ways to deprotect the alcohol. You can use strong acid, or you can use fluoride, which is much more more common way, because you don't have to. We try to avoid acid, like practically. Right? We don't want to touch the acid. Anyway, so we use a TBAF, tetrabutyl ammonium fluoride. We call TBAF. All right, so the whole synthesis should look like this. All right, we have to do Grignard here, but we can't because the OH group, we're going to protect it using TMSCl with triethylamine. All right, once you do, we have protected the alcohol, we're going to do the functional group transformation, add magnesium to it, so make a Grignard. Right, add the nucleophile, so this guy will go attack, you get this compound, and then we're going to work out adding water, adding acid to protonate that OH group. And finally, we have to deprotect the TMS group using TBAF. Here we go. All right, so three core steps: protection, functional group transformation. There's a lot going on in here. And then final step, deprotection. All right, how do we make this guy? Let's think about it. If you look at the structure of the product, can you see this guy right here? The whole compound can be made from nucleophilic attack from the Grignard reagent to the acetaldehyde. Look like that. So basically, we just convert this to a Grignard reagent, right here, Grignard reagent, right? But we can't do it directly because we've got an OH group on it, so we have to protect it first, right? So do protection, TMSCl, and then triethylamine, so you should get OTMS right here, so protect the alcohol. After the protection, we can do the functional group transformation, add magnesium, so you make a Grignard reagent, and then add acetaldehyde. Watch out right here. So again, just like LAH, we talked about this before, the carbonyl carbon is flat. Nucleophile can approach from the top, from the bottom. You should get two products here. And then we're gonna add water, so two protonate and the oxide and oxide here, and also quench or destroy the leftover magnesium bromide. The Grignard reagent is really nucleophilic, so we're gonna stop the reaction. Right? So you should get this right here. And final step is deprotect the TMS group, look like that, using TBAP, right? These are diastereomer, not enantiomers. Okay. All right, now be familiar with the mechanism. So the mechanism of the Grignard reagent and LAH are awfully look a lot alike. So be familiar with it. And this one do the synthesis. Okay, use a protecting group. All right, have fun, guys.